Hello everybody, I'm Mark Tewksbury, your host of this program. Our goal is to reveal the methods and materials that turn out the everyday products we see around us, from toothpicks to computers to airplanes. If you think you know something about these items, you might be in for a surprise. There's a whole world of things to discover here on How It's Made. We can now grow molecules by gene implantation in plants and animals. Take the goat. Within its body, we can grow very strong fiber molecules used to save lives. We're not talking medication, though. With fiber-producing goats, we can make, of all things, bulletproof vests. In this program, toothpicks, acrylic bathtubs, helicopters, and beer. Some people use them to build models of the Eiffel Tower, others to hold hors d'oeuvres together, and some people use them to pick their teeth. What are we talking about? The toothpick. Logs. Lots of birch logs are delivered to this factory. They're the raw material with which toothpicks will be made. The heavy logs are lifted by grippers and placed into a debarker. Bark isn't part of the fabrication process and is recovered by this machine. However, the bark isn't thrown away. It's sold to a neighboring factory where it will be used as fuel. The debarker works in two steps. With two passes, it produces a log roll that's perfectly cylindrical and easier to mill. This particular log of wood is being transported to the next processing stage. This unraveling machine unravels the log as if it were a roll of paper, cutting it with 12 fine blades, each 1.06 millimeters thick and 6.3 centimeters wide. These same blades will be used later to cut toothpicks. Then these 12 blades, positioned side by side on the unraveling machine, will form rolls of strips called billets. These tiny cutters are used to trim the ends of the toothpicks. Knives placed here and there on the machine thin the ends of the toothpicks. The roller rolls out the cut strips, forming a billet. Completed strips, or billets, are taken out manually. Each billet weighs 1.8 kilos. The billets are carried to the puncher. The flat toothpick puncher cuts the billet strips into small, equal-sized pieces. The cut pieces come out at this end of the machine. The punch works very rapidly. Knives come down 2,000 times per minute to cut a total of 8,000 toothpicks in just 60 seconds. Cut toothpicks fall into this chute, then into a container. At this stage, they're soft. They have to be hardened in a dryer during 4 hours at 121 degrees centigrade. Then the toothpicks are transferred to the polisher. Talcum powder and friction help make the toothpicks perfectly smooth. This operation takes 4 hours. Toothpicks exit the polisher and pass through this sifter, which filters out broken ones. Those in good condition continue on to an air blower system. Damaged ones are rejected. Perfect toothpicks are placed onto two conveyors by an air blowing system. Drums at the end of the conveyors assure quantity distribution, then they're carried toward the automatic packagers. This machine counts the toothpicks. Boxes are made up, ready for filling. The number of toothpicks included in each box counts. The packager is calibrated to place 650 toothpicks per container, and it produces about 1,150 boxes an hour. It thus handles 747,500 toothpicks every hour. Some toothpicks are individually wrapped for distribution to restaurants and airlines. This machine wraps 1,200 toothpicks per minute. It automatically wraps, glues, and cuts the paper. This facility can manufacture the astronomical number of 20,217,600 toothpicks every day, and all this starting from a few birch logs. Sometimes taking a bath is a necessity, but soaking in today's sleek bathtubs can also be an experience in supreme luxury. Modern bathtubs look nothing like tubs of the Middle Ages or those wooden tubs we see in Western films. To achieve supreme comfort, the designer explores new shapes via computer and design software, tools which make for speedy review of various shapes. Then a model is produced. This one, produced on a 1/6 scale, is made of cardboard, but other models can be made of clay, polystyrene, or by stereolithography. Manufacturing begins with an acrylic sheet. It is heated to about 200 degrees centigrade with ceramic elements. The sheet becomes soft and malleable. So that it takes the form of the mold, thousands of tiny holes in the shell suction the sheet by vacuum. The mold must cool before it can be opened. Powerful ventilators blow air directly onto the mold, lowering the temperature to 77 degrees in 4 to 6 minutes. The ventilators are then withdrawn. Then the shell is easily removed from the mold, and that's because it weighs a mere 16 kilos. To make a tub in another shape, they change the mold. They put it in another acrylic sheet. It is heated on the ceramic and fiberglass mold. The little holes vacuum out air, and the job is done. At any rate, the molded acrylic sheet is not sturdy enough to be filled with water, so it must be reinforced with fiberglass. This is the fiberglass. Mixed with resin, it is blown onto the mold by a robotic unit. Stored in reservoirs, the resin is carried to the robot by pumps. Here it produces a chemical reaction between the fiberglass and the resin, which produces a reinforced shell. Laminating is one of the most important steps. With brush and roller, they eliminate all air bubbles which could weaken the tub. This makes the fiberglass resin adhere perfectly to the acrylic shell. The process requires 75 minutes. The shell is then transported to the milling department. The shell is now dry and hard. They can extract it manually, but here they use digitally controlled machines. The operation begins with the trimming of the edges of the bathtub. During this operation, the robot will also pierce openings for the drains, the whirlpool jets and the air jets, for the overflow as well as for ambiance light. The bathtub, almost completed, is now sent to another workshop. They can now install the pump, the piping, and the blower. These last operations are done manually. The pump is installed for the whirlpool system as well as the PVC pipes, whose joints have been hermetically sealed to prevent any leaks. Finally, to make sure that everything is functioning well, each bathtub undergoes a water test. Some 13 steps have elapsed, plus 3 to 5 hours of work depending on the tub being made. It almost invites you to climb in. If I could pick my favorite aircraft, I'd pick the helicopter. Why? It can go anywhere, move in almost any direction, and take off and land in the most difficult situations. Man has always wanted to fly, and the versatility of the helicopter has allowed him to reach unexpected heights. Plans for a helicopter were created with CATCHA 3D, design assisting computer software. It takes 700 hours of work between the drawing stage and assembly of the pattern. The helicopter is made of carbon fiber, a composite material lighter and stronger than steel, protected by 2 layers of green plastic. The fiber is cut with a blade controlled by ultrasound. They lay on several thicknesses of fiber to make the rear fuselage. The green light of a laser helps position the parts. Then with a heat gun, they apply a beehive web, which increases the solidity of the structure. But the carbon fiber is still soft. To harden, it must be washed under pressure for 10 hours in this autoclave oven at 177 degrees centigrade. The pieces exit the oven and head for machining. The door of the motor housing is kept in a cutting jig and is shaped with a manual shaper. Before installing the parts in place, they strike it with a resonance hammer to detect any faults. Next, the electrical harness is mounted on a pattern before being installed in the aircraft. This particular helicopter has 2,351 meters of wiring, but others can have almost 9 kilometers. The wiring will be connected to the flight instruments panel, the brain of the helicopter. This aircraft has 9,964 rivets, fastened with a gun and a ram. They also apply a sealant to prevent the infiltration of corrosion, creating humidity. They now assemble the helicopter's rear fuselage. Piece by piece, the aircraft takes shape. They will install mechanical components later. The motor arrives. This one weighs 120 kilos and has to be carefully handled. Among the other parts to be installed is the circular plate on which the blades will be attached. Safety is primary. The screw nut holes are perforated, allowing the insertion of the brake cable. This tightly braided metal wire prevents the nut from loosening due to strong vibrations. Now they bolt on the 4 blades which make the helicopter fly. Weighing 41 kilos each, they're made of composite materials and an aluminum alloy. They're attached to the main rotor. The dashboard is installed in the cockpit, and all the wires are hooked up. Contact is established, and all is functioning properly. Nothing remains but finishing the interior of the craft. They install seats, safety belts, the consoles, bulkheads, windows and doors, as well as the trimmings. The helicopter is almost completed, but it still has to be painted. When done, the helicopter is towed outside the assembly hangar. Flight tests are performed to make sure that mechanical and electrical components are functioning properly. It requires an average of 110 days to assemble the 3,419 parts of a helicopter like this one, and they turn out almost 185 units each year. These 2.8-ton aircraft are capable of reaching speeds of 140 knots and flying at a maximum altitude of 6,096 meters. Ancient people brewed this flavorful beverage with malted barley and hops. Today we use much the same ingredients to make beer, but with a production